What are these traits all about? There certainly seems to be something biological about it. There's no question about that. How do we know that? Because we give these kids, or adults for that matter, medication, and they calm down. In fact, paradoxically, we give them stimulants, and they calm down with the stimulants. And that's an interesting question as to why stimulants will actually make somebody less active. And I'll talk about that later. But the point is that there appears to be a relative lack of a chemical on the brain called dopamine. Dopamine is necessary for focus, attention, and for motivation particularly. And what the medications given for ADD do, such as methylphenidate, otherwise known as Ritalin, and by other trade names like Concerta, for example, or dexedrine, which is another stimulant, what they do is they elevate levels of dopamine in the brain. So by altering the biology of the brain, we're getting alterations, improvements actually, in focusing and the calming of behavior. So there seems to be seen to be a biological component to it. And on some brain imaging studies, like brain scans, they have shown in the brains of ADD adults deficient energy utilization in the part of the brain that makes decisions, particularly under stress. And in one study of children with attention deficit disorder, they looked at electroencephalograms, EEGs, electrical readouts of the neurological activity of the brain. And these adolescents with ADD were compared to a group of boys who didn't have ADD, and at rest, their EEGs, their brainwave patterns looked the same, but when they gave them a math problem, instead of increasing fast wave activity, which is what you expect when the brain is doing work, which is what happened in the control group, in the ADD group, you actually had increased slow wave activity. So the brain actually slowed down under pressure of having to do this math problem. The real question is, what is the biology of, and there are other findings that are not unique to ADD in the brain, but seem to be characteristic of it. Now the question is, what is this all about? The dominant medical view, as is the dominant medical view of many conditions, is that we're dealing here with an inherited genetic disorder. In fact, some people assert that ADD is the most heritable disorder there is. Now, I argue that that's complete nonsense, that there's actually very little about ADD that's genetic. And as I modestly point out to people, there are two opinions on ADD. There's mine and everybody else's. The problem is that the other people who have written about ADD have not actually looked at the fundamental question of how does the human brain actually develop. And I won't spend too much time on debunking the genetic perspective, but I'll make the obvious point that just because something runs in a family doesn't make it genetic. I'm a medical doctor and used to be a teacher actually. If one of my children becomes a physician or a teacher, that would not automatically prove that the practice of medicine or that of pedagogy are genetically inherited disorders, now would it? Point is that conditions can be recreated from one generation to the next in which similar development takes place. What do we actually know about human brain development? And this information is no longer controversial. In fact, it's incontrovertible. It's generally accepted in brain science circles. The details are being worked out, but much already has been demonstrated and delineated. Unfortunately, this information is not yet taught in the medical schools, nor is it introduced yet into faculties of education. But here's the point. The point is that the human brain develops largely under the impact of the environment. Which circuits develop and which don't depend on environmental input. Well, that's not news to anybody who's ever gardened, for example. A gardener knows very well that a plant, given the right conditions, will thrive, but deprived of nutrition, minerals, irrigation, or sunlight, it will wither or simply not perform as well as it otherwise might. It's the same thing with the human brain. The same thing with the human brain. As a matter of fact, more so with the human brain than that of any other animal. That's for the simple reason that we're fundamentally born with brains that are premature at birth compared to all other mammals. A horse can run on the first day of life. A human being cannot muster that much neuromuscular coordination, balance, visual acuity, strength, and so on until the second year of life. In other words, the horse is 2 years ahead of us in terms of brain development at the moment of birth. And why is that? It's a simple evolutionary fact. Our progenitors began to use the forepaws as hands, first as digits, opposing the thumb against the hand, which then promoted tremendous brain development, because in order to use the hand and to manipulate the digits and to plan their activities, you need a lot of brain power. So there was an evolutionary selection for larger, more complex brains created by the use of the hand. So now we have this large head as a human being. At the same time, we began to walk on 2 legs, which meant that the pelvis had to narrow. So now you have a large head, narrow pelvis, and anybody who's ever given birth or has seen a birth will know exactly what the consequence would be if we weren't born at 9 months. The consequence would be we never would be born, because already at birth, at 9 months, the head is the largest diameter of the body. If anything gets stuck in the birth canal, it's usually the head. And that means we have to get out of there with relatively premature brains, and that means that following birth, there's tremendous expansion in the human brain size, which mostly occurs in the first 3 years of life. There are times in the first year of life when every second millions of connections are being made, literally millions of connections every second, and by the end of the 3rd year of life, the human brain is 80% adult size, the human body is 19% adult size. Now, which circuits develop and which don't depend largely on environmental input. If you take a child with perfectly good eyes at birth and you put him in a dark room for 5 years so that he never sees light, he'll be blind thereafter for the rest of his life, because the visual circuitry, the 30 or so circuits that make up the brain's visual apparatus, culminating in the visual cortex at the back of the brain, those circuits don't develop without the input of light waves. And even the ones that are present, the rudimentary visual capacity that's present at birth, atrophies and dies if no light waves enter the child's eyes for 5 years. If you look at the circuitry of impulse regulation, of attention regulation, of behavior self-regulation, that also requires the appropriate input from the environment. And just as the visual circuitry requires light waves, so the circuitry of emotional self-regulation, attention, and impulse regulation requires the presence of a non-stressed, emotionally available, consistently available parenting caregiver. So, again, the development of these essential circuits depend upon an emotionally nurturing relationship with adults. And I'm not talking here about how much the adults love the child or how dedicated they are. It's a question of how stressed the adults are and what that stress on the adults means for the child development. Because children who are stressed, I should rephrase that, adults who are stressed, parents who are stressed, pass on their stresses to their children without meaning to do so. But if you look at the cortisol levels, for example, cortisol is the body's stress hormone. If you look at the cortisol levels of children 3 years of age whose mothers were depressed in the first year of their lives, in other words, had postpartum depression, those children have elevated cortisol levels. In other words, the child's stress levels physiologically were determined by the parents' emotional states. I mentioned the chemical dopamine. If you take infant monkeys and measure the dopamine levels after 2 or 3 days of separation from mother, you'll find the dopamine levels normal in the brain everywhere except in the frontal cortex where behavior regulation takes place. In other words, in the frontal cortex, which is where these circuits are located, the sufficient presence of dopamine depends on the emotional interaction with the parent. At the University of Washington in Seattle, they did EEGs, again, electroencephalograms, of the infants, 6-month-old infants of depressed mothers. Comparing them to the EEGs, the readout of the electrical activity of the brains of infants whose mothers were not depressed, they could tell from the EEG of the infant whose mother was depressed and whose wasn't. Now, why is that? The first point we need to make here, that this has nothing to do with blaming mothers or blaming parents in general. No one chooses to be depressed. deliberately. No one chooses to be stressed deliberately. The point again isn't whether we love the child, whether we feel attached to the child, whether we're dedicated to the child. That's all given. The point is, how stressed are we and what are our emotional states? And that depends a lot on the nurturing environment, not just on the individual parent. And I'll say more about that in a moment. But the reason that parental mood states and emotional states and stress levels affect the infants is that infants have no capacity for regulating themselves. The development of their self-regulatory system depends purely on the interaction with the parent. A child who's never picked up, you can change his diapers and feed him, but if you never pick him up, an infant, he'll die. Why? Because he'll stress himself to death. The stress hormones will be totally out of control. He's got no regulation on that whatsoever. He's regulated by the emotional nurturing of the parent. I'm not suggesting that kids with ADD were never picked up. What I'm saying is that the parents of ADD, invariably, according to many of the studies, certainly according to all my own research, and including my own children, the parents were stressed, and it was the stresses, not genetic factors, that accounted for the failure of optimal brain development in these children. Think about the question of tuning out for a moment. What is tuning out, which is the hallmark of ADD? Now, tuning out actually is a nature-given capacity of self-defense. People tune out when they're stressed, and if they're helpless. If I'm stressed as an adult, I have options. I can leave the stressful situation, I can change it by fighting back or just altering the circumstances, or I can seek help. Only if I'm not able to do any of those things, and if the stress is sufficient to overwhelm me, then my brain will go into automatic tune-out mode so that I'm not aware of this unbearable vulnerability that I have. It's a natural defense of the brain. I don't do it, the brain does it. Now, think of the infant now living in a stressed environment. When I say stressed, I don't mean anything extraordinary. I just mean stresses that the parents aren't quite aware of in themselves and therefore cannot protect the child from. The child is stressed, physiologically stressed, emotionally stressed, can't fight back, can't change the situation, can't escape. He goes into tune-out mode. He goes into tune-out mode at a time when every second the brain is making millions of connections. The tune-out mode becomes the default setting of the brain. And then later on he has to work hard not to be in tune-out mode. So for me, it's effort to pay attention when I'm not highly interested in something. I could say more about brain development. That there's been many, many studies now that showing that actually the genes in the brain are turned on and off by the environment, that even if somebody has some genes, for example, predisposing to addiction, that gene can be turned off by nurturing parenting. But the quality that's lacking in the parenting of many troubled kids, not just with ADD but other developmental disorders, is the quality of attunement. Attunement means being in tune with. Attunement means getting the emotional space of the other person, sharing it, and communicating that I'm sharing that space. With infants, we do this intuitively and automatically. If we see a baby crying, we go, "Aw." Our face itself becomes a mask of sadness, and we're communicating in our body language and our tone that, "Hey, baby, you're sad. I get that you're sad, and I'm sharing your sadness because I'm sad that you're sad." That's what attunement is. Parents who are stressed, themselves absent perhaps in their minds, who are depressed, they're not able to attune with the child. And from the physiological point of view, it's the looks in the parent's face, it's the size of the parent's pupils, it's the relaxation or tension in the parent's voice, it's the tenseness or fluidity of the parent's body language that has the impact on the child's brain development.